Welcome to Math Time. This is Miss Janelle reminding you that to learn math is to do math. In our previous discussion, we solved linear equation graphically or by graphing. Graphing helps us visualize the solution of a system of equations, but solving by graphing is not always accurate nor fast, especially when the solutions are not integers. Oftentimes, graphs are used to approximate the solution. To obtain exact solution, we use algebraic method. Thus, our next lesson is all about solving system of linear equations algebraically. For today's objective, we have first, given a system of linear equation in two variables, find the solution of the system algebraically. First is by substitution method. Second is by elimination method. Second, apply the substitution principle to check whether the answer obtained is or are correct. In solving system of linear equations algebraically, we have two methods. First is by substitution, second is by elimination. Let us first discuss by substitution method. So how do we use substitution method? First, solve one of the equations for either x or y. Second, substitute the expression obtained in step 1 into the other equation. Third, solve the resulting equation in one variable. Fourth, find the value of the other variable by substituting the solution found in step 3 into any containing both variables. Lastly, check the solution in the original equations. Let's have this guessing game. Miss Galarin asked the class to guess the number of chocolates and candies in the jars. She gives the following clues. First, the number of chocolates added twice the number of candies is 33. Second, the number of chocolates is 6 less than the number of candies. Question: how many chocolates and candies are there? To solve this word problem, we will use the elimination method. First is we let x be the value of, x is equal to the number of chocolates, while variable y, let it be equal to the number of candies. Okay? Next is we translate this verbal phrases into an algebraic expression. So let's use Miss Galarin clues. Okay, so the number of chocolates, that is x, added to twice the number of candies. Twice the number of candies, that means that is 2y, is, please take note that is equal sign, 33. Okay, so here's the first clue. Second one, the number of chocolates is less than the number of candies. The number of chocolates is 6 less than the number of candies. 6 less than the number of candies. Please take note that 6 less than the number of candies is different from 6 less the number of candies. Okay, that's different. Again, we're gonna use substitution method in solving this system of linear equations. So as you can see, we have here our first equation and here's our second equation. Let's write it here. X plus 2y is equal to 33 and x is equal to y minus 6. Equation 2, let's write it here, 1 and 2. As you can see in equation 2, x is equal to y minus 6. Again, we're going to use the substitution method. Therefore, we're going to solve one of the equation for either x or y. So we will use this as the value of our x. Okay, wait. Let's put it here. Again, we're gonna use this value. X is equal to y minus 6 as the value of our x. So we substitute this x. Instead of x, it will be y minus 6 plus 2y is equal to 33. Okay? And then just eliminate this parenthesis. We will have y plus 2y, that is 3y, is equal to 33. We have here minus 6. We put it into the other side, so that will be plus 6. 3y is equal to 39. Therefore, y is equal to 13. Dividing both sides by 3, that is 13. And we already have the value for variable y. Now, as we solve the value of x by this y. So let's use the second equation. X is equal to y minus 6. Again, you already know the value of y, so just substitute it here. That's why that's called substitution. X is equal to 13 minus 6. Therefore, x is equal to 7. And there you have it. You already have the value of your x and the value of your y. So this is the solution for our system of linear equation. Last step, we will check if our solution is correct. So let's substitute this ordered pair to each equation in the system. Let's start with the first equation. X plus 2y is equal to 33. Again, the value of your x is 7 plus 2, and the value of your y is 13. Is equal to 33. 7 plus 2 times 13, that is 26. Is it equal to 33? Let's see. 7 plus 26, that is 33. And yes, it is equal to 33. So, this ordered pair is true for our first equation. Let's have our second equation. X is equal to y minus 6. Again, your x is 7 and your y is 13. So 7 is equal to 13 minus 6. Yes, that is 7. Okay? Since this ordered pair is true for our first and second equation, meaning this is the solution for our system of linear equation. Let's have another example. X minus 2y is equal to 6 and 3x minus 2y is equal to 12. So for this one, again, our first step is we solve for one variable. Since in this two equation, it is easier to find the value of y in our first equation. So let's solve for the value of x here. Let me write it here. X minus 2y is equal to 6. Okay, let me just get the value of x. X is equal to, let's transpose negative 2y. It will be 2y. Positive 2y plus 6. And we already have the value of our x. Next step is let me put it here. Step 1, solve for x. Second step, let me write it here. Step number 2 is we substitute the expression into the equation. Substitute the expression or the x to the next equation. Okay, so we will have 3x minus 2y is equal to 12. Again, we will substitute the value of our x here into this equation. So 3 times the value of your x is 2y plus 6 minus 2y is equal to 12. Okay, so let's apply the distributive property. 3 times 2y, that is 6y. Next, 3 times 6, that is positive 18. Minus 2y is equal to 12. Combining like terms, we will have 6y minus 2y, that is 4y, is equal to 12. Then let's transpose positive 18 to the other side. This will be minus 18. Thus, we have 4y is equal to 12 minus 18, that is negative 6. Dividing both sides by 4. 4y divided by 4, that is y, is equal to negative 6 divided by 4, that is negative 3 over 2. And we already have the value of your y. Okay, so step number 3. For step number 3, now that we obtained the value of our y, let's substitute the value of your I to our equation to get the value of x. Okay, so let's use equation number 1 since it's easier. X minus 2y, or in step number 3 already. So x minus 2y is equal to 6. Again, you already have the value of your y. Let's substitute it here. X minus 2 times negative 3 over 2 is equal to 6. So we will have x, as you can see, negative 2 times negative 3 over 2. For you to see it clearly, it looks like this. Okay, so we could cancel out this and this. So I'll have negative 1 times negative 3, that is positive 3. So x plus 3 is equal to 6. By transposition, x is equal to 6 minus 3, that is 3. Okay, x is equal to 3. And there you have it. Here's the value for our x and y. We have 3 and negative 3 over 2. So here's the solution to our system of linear equation. So let's check whether the solution that we get is correct or not. So again, we have 3 and negative 3 over 2 for our variable y. So to check, we will just substitute this ordered pair, or the value for x and y, to our equation. Equation 1, equation 2. So for equation 1, we have x minus 2y is equal to 6. So let's substitute 3 minus 2 times negative 3 over 2. Is it equal to 6? Let's see. So 3 minus this one. So we can cancel out this and this. Negative 1 times negative 3, that is positive 3. And yes, 3 plus 3 is equal to 6. Therefore, our solution is correct already with our first equation. Let's proceed to our second equation. 3x minus 2y is equal to 12. Again, let's substitute the value for x here. 3 times 3 minus 2 times negative 3 over 2. Is it equal to 12? So we have here 3 plus 3, that is 9, and we have negative 2 times negative 3 over 2. This is just equals to positive 3. And yes, 9 plus 3 is equal to 12 as well. Therefore, since this solution, this ordered pair is both correct for our two equation, this is the solution to our system of linear equation.